Alright, hello once again, Jeff Scott of Rankin Technical College. I've been going over a series of video presentations for the Rankin Technical College AWD Application and Web Development 1111 .NET Framework with Web Databases class. The main textbook to be used for the class is ASP.NET MVC with Entity Framework and CSS by Lee Naylor. Before we're going into that, though, we're going through several chapters of Professional ASP.NET MVC 5 by John Galloway and others. And I am in the middle of Chapter 7. And I'm to the point now where what the author is going to do is to start talking about some of the threats that you would most often have as a user. First one that's discussed here is cross-site scripting. Now, it says cross-site scripting can be carried out in two ways. By a user entering a nasty, typically JavaScript commands into a website that accepts unsanitized user input, normally into form fields, or by user input being directly displayed on a page. The first type is called passive injection. The second type is called active injection. Now they're going to show some examples here. But the idea is this. Let's suppose that I have here that this is a form. It asks for my name. And I go, and where it says your name, I put in there something that looks like this. All right, and you might, when I first put it in there, you might look at it and go, why would you ever want to do that? Well, just bear with me. So imagine there where it says your name, I type in this. Now, I go in and let's just suppose right there, I don't even put anything else in. I don't put in the email, etc. But I click the button. There probably is a button down there someplace for submit. Okay? And it comes back and I get a JavaScript alert box that comes up here that says hello. What that means as a potential malicious person is I've kind of hit jackpot right there. All that script does is it says hello. Well, that isn't anything bad. But instead of that, what if I put evil JavaScript commands in here to bring the site down, to corrupt the site, to attempt to find information from people who are using this site, etc. All right? Again, that's passive injection. Now it says, notice what they say here. This isn't a direct attack, but you placed a less than sign in the URL to see if it's encoded as this or as this. There's a big difference. This has been sanitized because it's the HTML entity. This has not been sanitized. All right? And they go through this. Again, I'm not going to go through it in any more depth than that, but it allows you to put in stuff like this. Now, you wouldn't have this. If somebody was maliciously attacking a system, they wouldn't give you a message, typically, that says you have been hacked. But, you know, a lot of times people think this isn't that big a thing. Let me just tell you a side story here. And that is that I went to a conference on the PHP programming language, probably now I would guess somewhere around 7 or more years ago. It was in San Diego, California. I went there for two reasons. One was they provided a day's worth of training, and then they allowed you to sit for PHP certification, which I did and received in PHP 5.3. And the other thing was they had a series of presentations, all right, on different topics. One of the ones that I went to on the end of the first day was on cross-site scripting, XSS. And it was interesting because most of these presentations were the whole thing was at a hotel. Most of them were like in smaller ballrooms that would basically hold 25 to, you could probably pack in 50 people. When I went to this one, and like I said, remember it was in the afternoon on the first day, there probably were closer to 200 people. They were out the door. People were standing up to 30 or 40 feet out the door to try to listen to this guy. They had to give him a stronger microphone so people could hear him. So not only is it an important topic, but it's one that can affect anybody. So that was the passive injection. With the active injection, as it says right there, it involves a user sending malicious information that is immediately shown on the page and not stored in the database. It's called active because it involves the user's participation. All right. Now, I'm not going to go through this example. I will just tell you, it goes along. Maybe this isn't the exact thing here, but, we've all gotten those emails that are not from somebody you know, but it seems like it's from somebody you know, and it tells you to click on a website or whatever. Don't do that, of course. But I remember that happening a while back, and 2 of my 3 daughters, this was many years ago, maybe you heard about this, there was, I don't remember if it was a picture of Beyonce or a link to Beyonce, but it was something where you clicked it, and you were supposed to get additional information. Well, what it did was basically it started to infect the hard drive on your machine. That was active. All right, that was active injection, in my opinion. So how do you prevent this? As it says, most of the time you can avoid cross-site scripting by using simple HTML encoding. So again, converting characters like this to an ampersand LT semicolon and an ampersand GT semicolon. You can do this with MVC in the view by simply using html.encode or html.attribute.encode. Again, notice what the author says here. If you get only one thing from this chapter, please let it be this. Every bit of output on your pages should be HTML encoded or HTML attribute encoded. HTML.encode is your friend. And they show some examples on how you can put it in. Not all server controls protect against cross-site scripting, but the overall web-form package tends to push people in a safer direction. MVC offers you more freedom, but it also allows you some protections right out of the box. Using HTML helpers, for example, encodes your HTML as well as encodes the attribute values for each tag. HTML.attribute.encode and URL.encode, notice it says there, most of the time the HTML output on the page gets all the attention. However, protecting any attributes dynamically set in your HTML is also important. All right. It goes back to what the author mentioned before. Never, ever trust any data that your user can somehow touch or use. Form values, URLs, cookies, personal information from third-party sources. Assume that it's bad. Sanitize it. All right? It's the old, shampoo, wet your hair, lather, rinse, repeat type of an idea. It almost seems like it's in an infinite loop. Just HTML encoding everything isn't necessarily enough, though, is what it says right here. let's take a look at a simple exploit that takes advantage of the fact that HTML encoding doesn't prevent JavaScript from executing. So they go through a way that JavaScript can be put in. It says this looks great because your HTML encoding the viewBag value. You're perfectly safe, right? No, you're not. And it says the following URL will allow things to slip through. There's an example. Again, you're able to put in a very simple alert. All right. What happened? It says, remember that you were HTML encoding, not JavaScript encoding. There are two solutions to this problem. The narrow solution is to use the ajax.javascript string encode helper method. All right. A more thorough solution is to use the anti-cross-site scripting library that has come with ASP.NET for quite a while. Of course, they're going to try to sell you on their product. It uses a whitelist of allowed characters, whereas ASP.NET's default uses a limitless blacklist of disallowed characters. So with whitelisting, you're trying to show everything that's valid and you disallow the rest. With blacklisting, you're trying to show all the bad characters and you allow the rest. They both can be problematic. All right. Most people will tell you, they have a preference of one over the other. The anti-cross site scripting library is focused on preventing security vulnerabilities in applications, whereas ASP.NET encoding is primarily focused on preventing display problems due to broken HTMLs. Okay. Here's another one, cross-site request forgery, Csrf. Can be more potent than simple cross-site scripting. Now it says, let's look at one case, cross-site scripting plus a confused deputy. We've already discussed cross-site scripting, but the term confused deputy is new and worth discussing. Wikipedia describes a confused deputy attack as a computer program that is innocently fooled by some other party into misusing its authority. It is a specific type of privilege escalation. In this case, that deputy is your browser, and it's being tricked into misusing its authority in representing you to a remote website. And they come up with a very contrived example in here. All right, where a person logs in one day and puts in this mildly malicious image tag. It says, now whenever anyone visits the page, this image will be requested. All right, and it's sort of the type of thing where it's getting information from you. It might be able to go in and get in information. So the example, like I said, again, that's in here is just bizarre. You log in and it says, hey, did you know that if you're a customer, that the sum of the digits in your account number always add up to 30? If you're interested, have a look. And if they click there, you're logging out of the site and you're logging back in with basically a fake account. The idea is this: they're getting control, the potential attacker, and they may say to you, hey, oh, sorry, there was a problem, you have to log in again. And then when you log in again, they're able to go in and get your login information. I remember hearing something on TV a while back. When I say a while back, I should only say probably about 10 days ago, where they were talking about all the attacks that people had been trying to promote or do on banks in North Korea. And they had asked for, around $1 billion, in fake, different attacks like this. And that North Korea was basically bragging about the fact that those attackers only got about 100 million. Well, 100 million is chump change. You know, so some people got in and were able to do things they weren't supposed to do. All right, it says you might think this kind of thing should be solved by the framework, and it is. ASP.NET MVC puts the power in your hands. ASP.NET MVC includes a nice way of preventing Csrf attacks, and it works on the principle of verifying that the user who submitted the data to the site did so willingly. And it goes through this and it talks about the anti-forgery token. And it says this handles most Csrf attacks, but not all of them. Idempotent gets, it says that's a big word, but it's a simple concept. If an operation is idempotent, it can be executed multiple times without changing the result. In general, a good general rule is that you can prevent a whole bunch of Csrf attacks by only changing things in your database or on your site by using post. We talked about that before. All right, cookie stealing. If you get online and you go out to a site, quite often some kind of a session ID is going to be put inside of some kind of a session cookie. If a malicious user can steal that cookie, they can, for all intents and purposes, become you. So as mentioned here, websites use cookies to store information between page requests and browsing sessions. Some of it's pretty tame. Others can have, more information. There's two types of cookies. There are session cookies stored in the browser's memory and persistent cookies, which are stored in actual text files on the computer's hard drive. The main difference, as it says, is that session cookies are typically forgotten either when the session ends or shortly thereafter, whereas persistent cookies are not. The site will remember them the next time you come along. You've all probably logged into a site at one time or other that you come back in and it says hello followed by your name or whatever. If you could manage to steal someone's authentication cookie for a website, you could effectively assume their identity. This type of exploit is actually very easy, but it relies on cross-site scripting vulnerabilities. The attacker must be able to inject a bit of script into the target site to steal the cookie. And they mentioned this even happened to Stack Overflow. So, how do you prevent cookie theft? Well, when this happened on Stack Overflow, it says it was facilitated by two things. There was a cross-site scripting vulnerability along with a cookie vulnerability. As mentioned there, you can stop script access to all cookies to your site by adding the simple flag HTTP only. The setting of this flag tells the browser to invalidate the cookie if anything but the server sets it or changes it. All right, just a little bit more in here. Overposting, as it says here, ASP.NET model binding is a powerful feature that greatly simplifies the process handling user input by automatically mapping input to model properties based on naming conventions. However, this presents another attack vector, so another potential way into the system. All right? I'm doing fine here, I think. This can allow your attacker an opportunity to populate model properties you didn't even put on your forms. ASP.NET model binding can present another attack vector through overposting. Here's an example. You have a simple form with only two fields you want to expose to a reviewer, name and comment. There's name, there's comment. Because you've only exposed name and comment on the form, you might not be expecting that a user could approve his or her own comment. However, a malicious user can easily meddle with a form post using any number of developer web tools and adding their own approved equal true to the query string or post data. The model binder has no idea what fields were included on the form and will happily set the approved property to true. What's even worse, because your review class has a product property, the hacker can also try posting values and fields with names such as product price, potentially altering values in a table you never expected, and users to be allowed to edit. The simplest way to prevent an overposting attack is to use the bind attribute to explicitly control which properties you want the model binder to find or to bind to. All right, notice right here. A second alternative is mentioned here, and we're on page 202 as I get myself caught back up here. Is to use one of the overloaded methods of update model or try update model that accepts a bind list. Brad Wilson wrote a good post that overviews the security implications of model validation, called Input Validation versus Model Validation. 2010, so it's a little dated, but probably still worth the read. Open redirection. Page 202, prior to ASP.NET MVC, the account controller was vulnerable to an open redirection attack. Any web app that redirects to a URL that is specified via the request, such as a query string or form data, can potentially be tampered with to redirect users to external malicious URL in an open direction attack. And I give an example of it right here. May not even be, you may or may not even notice this, but notice it says Nerd Dinner. Nerd Dinner. This is a famous thing. You can look this up in Microsoft, but the point is this says Nerd Dinner with 2 D's. Notice up here, and 2 N's. You're going not to Nerd Dinner, but to Nerd Diner. So what users will do is they will create these realistic looking websites that look virtually the same as the original and have you go to those. All right. So they'll push you off to a bad site that looks just like a good site. All right. Taking additional actions, this is page 207, when an open redirect attack is detected. As it says here, the account controller's open redirect check prevents the attack, but it doesn't notify you or the user that it has occurred. You may want to take additional actions, such as what's shown here. Again, open redirection attacks can occur when redirection URLs are passed as the parameters in the URL for an application. MVC 1 and 2 templates were vulnerable to this attack. MVC 3 and above include checks for open redirects in the account controller. Proper error reporting and the stack trace here on page 207. Quite often it mentions here, sites go into production with the custom errors mode equal off attribute set in web config. This isn't specific to ASP.NET, but it's worth bringing up in a security chapter because it happens too often. There are 3 possible settings for the custom error mode. On is the safest for production servers because it always hides error messages. Remote only shows generic errors to most users, but it exposes the full error messages to users with server access. The most vulnerable setting is off, which exposes detailed error messages to anyone who visits your website. So that's, typically the one that could be the most problematic. Detailed error messages can expose information about how an application works. For instance, if you've got an error in a database file, it can show you the name of the database, the name of the table, and the name of the field. Not good. If you need access to detailed errors on other servers, the author here recommends that you use the web.config transforms to manage the custom error setting based on build configuration. They show you an example here, and they say this includes a commented out section that replaces the custom errors mode with remote only when you build it in release mode. Turning this on is as simple as uncommenting something. All right. Using retail deployment configuration in production, page 209, rather than fiddle with individual configuration settings, you can make use of a handy yet sadly underutilized feature in ASP.NET, which is the retail deployment configuration. This simple switch in the server's machine.config tells ASP.NET whether it is running in retail deployment mode or not. The deployment configuration has only two settings, true or false. It defaults to false, and you can set it to true like this. What does that do? Well, it says it does a few things. Custom errors mode is set to on, which is the most secure setting. Trace output is disabled. Debug is disabled. These override any settings that were in web.config. The best solution is to never turn off custom errors in any environment. The author recommends that you make use of a dedicated error logging system like Elma, which is a free library available via NuGet and offers a variety of methods for viewing error information. And there's a link if you want more. Now the chapter ends here with a security recap and some helpful resources. So as you can see right here, the table that's on pages 210 and 211, actually it's a couple tables. The first table that's right here talks about the major types of security breaches that were discussed in this chapter. Plus complacency, which basically just means doing nothing. Educate yourself, cross-site scripting, encode, and use the anti-XSS. Cross-site request forgery, Csrf, use the token verification. Overposting, use the bind attribute to explicitly whitelist fields, and use blacklists sparingly. As it says here, ASP.NET gives you the tools you need to keep your website secure, but applying them wisely is up to you. So again, you know, it's like you buy a car that has air conditioning, but you never use the air because it hurts your mileage. All right? Sometimes you got to pick and choose what you do and when you do it and how you do it. Some extra security resources are shown here on the bottom. This is the Microsoft Security Developer Center. As mentioned to you previously when I did a bunch of presentations for a company, I used a lot of this stuff that's in here. I did a bunch with OWASP. I'll see if I can find that stuff, and if I can, I'll put it out there. All right. So, to finish up here and summarize, the author says, we started out this chapter and, this way, and ending it in this way is appropriate. ASP.NET gives you a lot of control, and it removes a lot of the abstraction some developers consider to be an obstacle. With greater freedom comes greater power. With greater power comes greater responsibility. The MVC team wants you to do the right thing. They talked about the fact that never trust any kind of input that comes into the system. As the author mentions here, there is no silver bullet when it comes to security. Security experts recommend that you respond with a strategy that's known as defense in depth. All right. It says it relies on layered safeguards, so that if one area of your security is breached, the entire system won't be compromised. Security issues in web apps invariably come down to very simple issues on the developer part. They either made bad assumptions, are going with misinformation, or have a lack of education. In this chapter, the authors did the best they could to at least start to illuminate you about the problems connected with security. All right, when we come back, we will go over Chapter 8, which is on Ajax. So that will be the next series of presentations. And I'll see you with those shortly.